Now coming towards question number 3, it says that is it possible for a form of heavy hydrogen to decay by emitting an alpha particle? Explain. So they are saying that is it possible for any form of hydrogen or heavy hydrogen? They are basically talking about deuterium. Deuterium is also called heavy hydrogen. Any form it can decay alpha particle or not. So the answer will be no. Any form of hydrogen cannot emit alpha particle. Why? Because we know that hydrogen has 3 isotopes: protium, deuterium and tritium. In protium we have 1 electron, 1 proton and 0 neutron. In deuterium we have 1 electron, 1 proton and 1 neutron. In tritium we have 1 electron, 1 proton and 1 neutron. Sorry, 2 neutron. Okay, so if we consider alpha, if we see for alpha case, for alpha we write helium as atomic number 2 and atomic mass 4. Alpha is composed of 2 electrons, 2 protons and 2 neutrons. So that is why it is impossible for any form of hydrogen to decay by alpha particle. Okay. Now coming towards question number 4, it says that different isotope of a given element have different masses, but they have the same chemical properties. Explain why chemical properties are unaffected by change of isotope. Do you remember one thing in isotope we have discussed that are those elements which are having same atomic number but different atomic masses known as isotopes. Okay, so isotopes are having same chemical property. Why? Because all they have same number of electrons. Why the isotopes physical properties are different? Because in each isotope the mass number is different. This is because in each isotope number of neutrons are different. So in the question they are saying that why all the isotopes have same chemical properties and why they have different physical properties. Why chemical properties are unaffected by change of isotope? Do remember, number of electrons and number of protons basically determines the chemical properties of a certain element, while atomic mass or mass number determines the physical properties of a certain element, like its melting, its boiling, its boiling, its density. These all are determined by mass number, right? So since mass numbers are in each isotope change, in each isotope the mass number is changed, that's why their physical properties varies, their physical properties changes, while number of electrons or number of protons in each isotope remains same. That is why all have same chemical properties, right? Mass number cannot affect the chemical properties. Mass number determines only the physical properties of the element. Okay. Now coming towards question number 5. Read the statement from the book. It says what fraction of radioactive sample has decayed after 2 half-lives elapsed? Means they are saying that if 2 half-lives are passed, how much amount of the sample will be left? Do remember one thing. For first half-life, the sample will reduce to half of the original. After passing the first half-life, the sample will reduce to half. After second half-life, the same sample will further reduce to half and it will give you 1/4. Mean after second half-life the sample will reduce to 1/4. Like the total amount, for example, I say, N naught is the initial total amount. Okay, for first half-life it will be N naught by 2. Okay, for second half-life this sample will be further reduced by 2 and it will give you N naught by 4. Okay, so this is how we do with question number 5. Okay, coming towards question number 6. What does it say in question number 6? Now we are going to do with the question number 6. Let me read the statement from the book. It says, can carbon 14 dating give the age of fossil dinosaur skeleton? Explain. Okay, we can say that, do remember one thing. In each living organism, it has a specific number of carbon 14 to carbon 12 specific ratio, and the metabolism is continuous until until the body is alive. Okay, when the body is alive, it has maximum ratio in that, right? When the body dies, after death, metabolism stops. So carbon 14 to carbon 12 ratio starts decreasing with the passage of time. And finally it comes and then after a very long time it turns to zero also. You know, carbon 14 has a half-life of 5700 years. 5700 years. Carbon 14 has a half-life of how much? 5700 years. Okay, this carbon 14 is used to date old fossils like 200 years, 300 years, 400 years, 500 years. Okay. So dinosaur skeleton is not that much old. Dinosaur skeleton is not that much old. It's very old fossil. So for dating very old fossil, we will use uranium-238 with a half-life of 4.53 into 10 to the power 9 years. For dating very old fossil, we will use what? We will use uranium-238 with half-life 4.53 into 10 to the power 9 years. So dinosaur skeleton cannot be dated with carbon 14. Why? Because it has a less half-life, 5700 years. To date very old fossil, we have to use uranium-238 with half-life of 4.53 into 10 to the power 9 years. Okay, it can be used to date even the oldest deposits on Earth. Do you remember? Uranium-238 can be used to date even the oldest deposits on Earth. Okay, so this was question number. So this was all about question number 6. Now coming towards question number 7. What does it say in question number 7? It says in question number 7, let me read the statement from the book. Okay, it says some food is treated with gamma radiation to kill bacteria. Okay, why is there not a concern that people who eat such food might be consuming food containing gamma radiation? You know, they are saying that you must have observed that we eat food like we eat some food which are not available in their specific season. For example, you can eat mango in winter also. You have ever thought that how it is possible? This is the food irradiation process. You know, food preservation process. In food preservation process, what does we do? We fall gamma rays on the food. So that gamma rays basically kill the bacteria inside the food. That gamma rays which we fall on the food is just to kill the bacteria inside the food. It has no concern with anything else in the food, right? Just this gamma rays we fall on the food just to preserve them and just to kill bacteria inside that, right? And it doesn't cause any sort of damage also. And all those people who think that this food which is treated with gamma rays are dangerous, so that is very common misconception. So it's not the thing like that. Basically what happens, the gamma rays what we use, it is just used to kill the bacteria inside the food. Okay, sometimes the taste changes, but there is no such harmful effects are there. Okay. You know, internationally, WHO, World Health Organization also supports food irradiation process. Okay, they also supports food irradiation process. Okay, so this was all about question number 6. Question number 7. Now coming towards question number 8. Question number 8. Let me read the statement from the book. What does it say? Radioactive alpha emitters are relatively harmless outside the body, but can be dangerous if ingested or inhaled. Explain. They are saying that radioactive alpha emitters are relatively harmless outside the body. Means alpha is basically harmless outside the body. Why? Because alpha has very less penetrating ability. Alpha's penetrating ability is very less. Alpha's penetrating ability is very less. It cannot pass through the skin. if we are exposed to alpha, so alpha can pass to our skin because it has less penetrating ability. Do remember one thing, even our clothing can block alpha. Even our clothing can block alpha because of less penetrating power of alpha. They are saying if it is ingested or inhaled, it is then dangerous. So we inhale alpha in form of radon gas. We inhale alpha in form of radon gas. Do remember, if this alpha is inhaled in form of radon gas, it may cause lungs cancer and it may cause radiation sickness and different lungs cancer, like it can lead to lungs cancer also. If ingested or inhaled, it may lead to lungs cancer and radiation sickness also. But if exposed outwardly, like it's not harmful outside the body. Why? Because it has less penetrating ability. It can pass to our skin, and even our clothing can block alpha particles. So this was all about question number 8. Okay, this was all about question number 8. And coming towards question number 9, it says, if nuclear radiation is harmful, how can we use the treatment for, how it can be used for the treatment of diseases? They are saying that as nuclear radiations are very harmful, so how we can use them to treat the different diseases? You know, for the treatment of different diseases, we use different radioisotopes, and we use different nuclear radiations for the treatment of cancerous cell, for goiter, for different problems, for dangerous tissues or cancerous cells or cancerous tissues destruction. We can use different radiation, different nuclear radiations. But why does not? How can we use them? So basically, they are asking that if nuclear radiations are harmful, how can we use them for the treatment of different diseases? And we know practically that different radioisotopes are used for the treatment of different diseases. For example, goiter, for example, to kill the cancerous cells, to destroy the cancerous tissues and different things. So basically, what radiations are, like nuclear radiations are used over there, but those radiations are not too much of high intensity. Those radiations are not too much of high intensity. Those radiations are not too much of high intensity. Pharmaceutical companies, they are just designing that, and they are just writing proper prescription or proper description of that how much they just apply a limit on that. Like if you use this much, it is not harmful. If you increase, if you use excess amount of it, if you use these nuclear radiation from a specific amount, like greater than a specific amount, then it can be harmful. So there is a proper boundaries for that, there is a proper dose for that, and they just give the patient a proper specific low dose prescribed by the doctors, and so they are used to treat the different diseases. But those nuclear radiations which are used to treat different diseases are very low intensity. Very rarely it is found that those patients which are exposed to nuclear radiation may have cancer afterwards, in life they may have cancer. It's very rare cases. Why? Because the nuclear radiation which was applied on that, they were of very low intensity, and that was not harmful. The function of those radiation was just to treat the disease only. So this was all about question number 9. So let me summarize today's work. What we have done in today's lecture, we have discussed all conceptual questions with very detail. You have to learn, memorize and practice all these questions. Revise also, learn, memorize and practice all these conceptual questions, and you have to write all these concepts in your notebook also, as we have discussed in class, and things are very clear to you, right? So this was all about today's lecture. Let me summarize today's work. In today's lecture, we have discussed all the conceptual questions of chapter number 18. From 1 to 9, we have discussed all. Okay. So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz. Fi Amanillah.